Good morning, everyone, and happy Earth Day. Thank you very much for joining us for today's Climate Action webinar, Building Collaborative Relationships, a Case Study in CLT. My name is Shalika Sivathasan, and I am the Administrative Assistant in the Continuing Education Department at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and who are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I would like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the needs of our diverse audience. In order to maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. Kindly note, the chat function has also been deactivated. However, we do highly encourage engagement through our Q&A window, which you will find at the bottom of your screen. Feel free to submit any questions you have for our speakers there. Questions will be addressed during the designated question and answer period at the end of the presentation. Excuse me. For those seeking continuing education learning hours, please note that attendance is crucial. A minimum of 80% attendance is required for these hours to be accredited to your OAA transcript. Please just allow a few weeks for the processing and reporting of these hours. And lastly, please note that the presenters do not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. Now, I'm excited to introduce our speakers for today's session, Stephanie Campbell and Sébastien Bernard. Stephanie Campbell is an architectural leader specializing in education and mass timber design. As practice lead for education K-12, she works closely with clients, project managers, and design teams to improve how education projects are delivered. She brings diverse perspectives together to create thoughtful, buildable, and usable spaces. And Sébastien is senior structural engineer whose responsibilities include structural analysis and design of new and existing buildings, preparation of construction designs, contract documents, cost options, and contract administration for the municipal, industrial, commercial, and institutional sectors. He is the firm's subject matter expert for mass timber, presenting at conferences in Canada and the US, while also leading internal lunch and learns for JLR. So please join me in welcoming Stephanie Campbell and Sébastien Bernard.
Thank you.
Thanks, Shalika. So the title of our presentation today is Building Collaborative Relationships, a Case Study in Cross-Laminated Timber, Biidaaban Kinoomaagegamik. The agenda today, so just quickly going through that, we'll have a quick introduction, we'll go through the learning objectives, and then we'll jump into collaboration with the client and community. We'll have an introduction to mass timber, to give some background on that topic. We'll run you through the design of the school to kind of orient you before we jump into collaboration, design, and construction. And we'll finish out with some closing thoughts and the Q&A at the end. So today we're going to talk about collaboration and CLT through a case study of Biidaaban Kinoomaagegamik, which is a K-8 school in Sagamok. A project like this requires a lot of people to work together towards the same goal. And here you see just a partial list of the organizations and people who worked collaboratively on this project. We have Sagamok, who is the community in which the school is located, as well as the client. JL Richards, JLR, that's us. And we have Colliers, who was the third-party project manager representing the client. ISC is Indigenous Services Canada, and that's the funder for this project. Matheson was the general contractor. Timmerman and Element 5 were both involved in the supply and installation of the CLT. And of course, there were many other contributors to the project, including mechanical and electrical subcontractors, etc. But these are the ones who are kind of the focus of this talk today. So this project is an opportunity to reflect on the process, decision-making, and delivery, and not just the finished building. So you'll get to see a lot of our thinking that went through into this process. And of all of those people, Sébastien and I are just two of them. So my name is Steph Campbell, and I came into the project when it was about 60% complete design. That's also when I started at JLR. And I took over as project manager and architect for the project.
And I'm Sébastien Bernard. I was the lead structural engineer on the project. I got involved around design development when kind of the project went into more of a mass timber direction. So some of the learning objectives for today, we want to understand how to build and sustain collaborative relationship with our clients, our communities, and our consultants. So Steph's going to cover a lot of the upfront collaboration process that that we went through and how that shaped some of the design decisions and also some of the design and construction. We're going to look into what mass timber is and how it can support low carbon building strategies and how it aligned with some of the goals for this client and the community. The meat of the presentation is a lot more around how to apply the lessons learned that we've gone through for CLT detailing, some of the impacts to specification and coordination, all in the light of collaboration and enhancing that. We're going to gain some insight into how to navigate supply chains and where kind of some of the delegated design and information gaps lie, and how that informed some of the design decisions and the lessons learned, and also how that impacts other disciplines outside of structural and architectural in terms of multi-trade coordination.
So at this point, we're going to ask everyone to participate in a quick poll that has to do with how your typical approach to client engagement. And so the question is, where do you typically focus your client and stakeholder engagement efforts? Designs are based on the requirements outlined in the RFP and then presented to the client. All engagement sessions and client design meetings happen in pre-design and schematic design. Client engagement and design meetings happen throughout all design phases. And the final option is engagement begins in the early design stages and continues through construction. Once a fair number of people have voted, we'll get to see the results and have a little discussion. All right, so I can see here we have about 5% of people chose option 1, which is just kind of basing the design off of the RFP requirements. 3% said that all engagement sessions happen in pre-design and schematic design. 32% was within the design phases. And 60%, which is incredible and great, is that engagement begins in early design stages and continues throughout the project into construction. So thank you for participating. That's great to see. Oh. Okay. So for us in this project, engagement was an active and ongoing process that did begin in the early design stages and continued through design development and detailed design, as well as into construction. It really helped us frame what was important to the client and made sure that we were, continually checking in and making sure that the design continued to be appropriate to what the client wanted as the design went on. These are just a couple of images from those really early community engagement sessions. This project is located in Sagamok Anishnawbek along the north channel of Lake Huron, where the Spanish River flows into the lake. You can see it there on the map, and a really beautiful image of the property as well. So as signatories to the Robinson-Huron Treaty, Sagamok Anishnawbek holds inherent rights to the land to govern community institutions, such as this educational one, and to maintain and express culture, language, and worldview. It's really important to understand that Sagamok Anishnawbek are rights holders and not just clients. And that helps us frame the relationship between us and the community as relational rather than transactional. We came into the project and into the community as guests to be, to provide our technical expertise. And our role was to support, translate, and enable the community to make decisions. We really attempted to build trusting relationships through consistent and respectful engagement, and with a focus on listening and learning. And I think that really helped us, work together to create this beautiful project that students and everybody love. But also those relationships that we built early on did help us, because as everyone knows, when challenges inevitably arise throughout a project, you need those strong foundations in relationships to deal with the difficult conversations and make sure that they maintain a respectful kind of tone. So some more images of our early engagement sessions. The one in the center was the first one that we did, where we brought some precedent images, engaged with students, teachers, community members, elders, teachers, staff members, and everyone, to tell us what they liked, what they didn't like, and have a discussion around those things. Then we took that information away, and we came back, and we were invited to attend the fall harvest in the community. So that's the image on the right and the left, where we got to participate in some of the activities, and then present sort of the work so far, which included bubble diagrams, a few more precedents, and we could discuss project goals, important adjacencies, and the desired function and feel of the school. So this was in 2019, and then in spring 2020, of course, we know what happened, and all of our engagement sessions went virtual. So these are just a few screenshots of the things that we discussed with the clients after, once we were into design development and detailed design. So things like, circulation throughout the site, how that approach would be, color selections, design of the millwork within each classroom, and how that would change for various age levels and sizes of children. So, across 4 different intensive kind of design sessions with the client groups, we invited the people who were kind of specific to what we were talking about that day, whether it was the teachers for the classrooms, sort of the special education workers who helped with the resource rooms and stuff like that, or the gym teacher who's telling us about gym storage. We really dug into the particulars of every space. And then also into construction, the client engaged us, after we had completed the design, and once they realized that, they needed some help selecting furniture, they engaged us to help them with those selections, including furniture types, material finishes, and also designing for flexibility within the classrooms. And at the, as we went through this process, this is kind of a summary of some of the things that we learned. So a few important things that we learned at the start were that safety and accessibility were extremely important, both outside of the school, around the site, in the approach, the way that children actually would travel to the school, as well as within the school. Connection to the land and cultural teachings were extremely important to them as well. That played into decisions regarding massing. So, for example, the main entrance, as you can see on the site, faces east and sort of greets the sun as children enter for the day. And the play yards kind of face south towards the lake and connection to the land that they have there. Other things that were important were language, and you'll see in some of the images of the school, the signage actually incorporates Anishnawbek as the first language on all of the signs, followed by English and then Braille. So that was a very cool thing to participate in, all those translations. Flexibility was important. So, creating spaces that could be used in multiple ways, but also, as the student population grows, some of the spaces which are currently now language rooms might become classrooms. And there's also provisions for additions to the building in the future. A sense of welcoming was really important. Making the building in such a way that it didn't feel institutional, and also that it was welcoming to the community. So we'll get to see some of those things later in the presentation. But the main thing that I wanted to talk about in terms of how that those discussions, the collaboration led into the design of the building is, we didn't actually know that it was going to be a mass timber building when we started. That came about through those conversations, and it started to make sense to use wood as the primary structural element in the school. For a number of reasons. It aligned with cultural values and climate considerations that Sagamok was thinking about, in terms of using renewable resources, bringing that warmth and natural material into the school, making it feel a little bit less institutional. But also for construction realities. This is quite a remote site. It's about an hour and a half west of Sudbury, to place it a little bit in your minds. And so being able to bring all of these CLT panels to site and erect them in a short order was pretty enticing, because the goal, of course, is to get the building enclosed as quickly as possible. And it was easier to do that with CLT than with CMU, which is a more typical construction material for schools. So we'll ask poll 2 to be shared. Question is, how familiar are you with mass timber? Very familiar. You've worked on 5 to 10 projects. Familiar, maybe 2 to 5 projects. Somewhat familiar. You've seen a presentation, or you've worked on a few projects, or you're not familiar at all. Okay, we have about 4% of people are very familiar, 17% are familiar. Somewhat familiar is the largest number, that's 53%, and not familiar at all is 26%. I will pass it off to Seb now.
So that's good to inform a little bit of the discussion. So now we're going to go into what is mass timber for those who are not as familiar with the material. So, it's an engineered wood product. So basically, the when you compare that to light wood frame or heavy timbers, you're taking the timbers and you're cutting them into smaller pieces, and then you're utilizing and filtering through some of the defects in order to optimize and make the most use out of the product. And so there's different ways and different materials that are available in the mass timber industry. Some of them are on the screen right now. So the one that we utilized on this project was cross-laminated timber. And so that process is basically taking various widths of plies and laminating them in a 90-degree fashion. So you end up with odd numbers of plies that generally starts at 3, and then 3, 5, 7, and up to 9. And so basically just varying those thicknesses, so you can imagine how thick things can get. The plies are usually around 35 millimeters, and there's a CSA standard in terms of how that is fabricated. Each of them have kind of their own unique properties, and so they should be utilized in different ways on a project. And we're going to go through some of the considerations next. But the other products that weren't utilized but are available, just for information purposes, the first is kind of laminated veneer lumber. So if you think of your plywood essentially, but in mass timber, that's just increasing the number of plies, and so you get with some very thick billets and thick panels. The other ones are kind of the standard ones that maybe people are more used to in the past. So NLT, which is your nailed laminated timber, those were used a lot in kind of the industrial and manufacturing in the past. And so basically the process of just nailing 2-bys on their side, and then the other two kind of offshoot of that are the glue or the dowel laminated timber. So same idea, but instead of laminating with nails, you're using tight fitting dowels that basically keep the laminates together. And then the standard glued laminated timber. So if you think of the post and beam type construction that more people are familiar with, that can also be used as a deck. So they're just kind of continued laminates and very wide members.
So I'm going to start talking about some of the considerations for mass timber. First one that everybody's going to think of is aesthetics. And so there's a few things to think about here. Number one would be shrinkage. So wood is a natural material, and over time, as the moisture content decreases, the wood will shrink. And when it comes to CLT, what that means is that each of the individual pieces, like boards that go into making the panel, will shrink, and you'll start to see little gaps in between the pieces. There's also natural defects, of course, with wood. It's, again, a natural material, so you'll see knots, a few other defects. And although, they try not to have the worst ones visible, there definitely are some things. And then we get into other things that aren't part of the material itself, but things that happen over the life of construction in the building. So moisture is something to consider for sure. As wood gets wet, if it's not taken care of, it can produce water stains, or worse, it could lead to mold. So that's definitely an important consideration for construction and needs to be integrated into specifications. Also, timber, like the mass timber, is one of the first things to be installed on site. And so how does that get protected from moisture, from construction activities and equipment and people walking through? And so, that also needs to be specified. And finally, there's the potential, of course, for vandalism. Wood is quite easy to mark up by accident or on purpose. And so that either just becomes part of the building, or you have to decide how you want to deal with it. And yeah. So next thing that I wanted to talk about is the speed of construction. So while the panels themselves can be erected very quickly, this requires careful organization and logistics. So for example, the panels, they need to be fabricated and then placed on the truck bed in order. And then they need to arrive on site exactly at the right time to be stood up in the building in the right order. So basically you want to kind of stack them in reverse order so that the correct one is on top, because multiple handling of each piece leads to damage, leads to extra time, and just kind of confusion on site. So that whole process can be quick, like I said, if it's organized well. The part that isn't that quick, which we learned on this project, was the lead time. So it's very extensive because there's a requirement for highly detailed and coordinated shop drawings. It has to be coordinated not only with the other structural elements, but also with the mechanical openings and doors and windows and placement of plumbing below slab and all of these things. And so that coordination takes quite a long time, and the fabrication can take quite a while as well. So those things definitely need to be considered in terms of the timing of construction. Time on site is quick, time prior to getting to site is long. Then there's cost implications. So while the material cost may be higher than other structural options you may choose, there are some trade-offs, and that can kind of help to offset those costs. So like I said, just with the speed of construction, when you can enclose the building quicker and spend less time on site, that does help with cost savings. And also, when wood is left exposed, of course, there's no need to cover it with other finishing materials. So there's some cost savings there as well. On average, it probably does still cost more than, say, if you would just build this out of CMU. But there's trade-offs, like I said.
So other considerations that played into our project and should be considered as well is the first is the state of the industry. So even just looking 5 years back, the overall industry has evolved quite a bit. So at the time, the number of suppliers and what they were and their capabilities is a lot different than what's available to us now. So that's definitely something that needs to be well understood. Supply chain, as Stephanie alluded to, in terms of the speed of construction. In our case, especially during COVID, there was definitely a push towards mass timber, and that put a big strain on the supply chain. It resulted in a big change on the project, and in terms of the successful supplier at the time was Nordique. But because of the supply chain challenges, they weren't actually able to get to materials to site until quite late, and that didn't really work with the project schedule as a whole. So that it required a change in suppliers actually after the contract was awarded. So it's just something that is very important. State of the industry in terms of guidance to designers as well. So anytime you're using a new material, there's limited guidance for designers, and also kind of less comfort in using the material. So that needs to be understood in design decisions, and how to maybe in some instances simplify design so that you can start with a simple project and then move on to some more complex things. So kind of also alludes to the state of industry in terms of the codes and regulations. In this project specifically, we utilized the 2015 NBC, and even in that, at that time, there was limitations in terms of fire separations and fire resistance rating for mass timber. So the code hadn't quite caught up to the industry in that sense. And now, when we look kind of forward into the 2020 or 2025, there's a lot more leniency in what can be done in, especially in terms of fire. When you think of fire resistance rating of structural elements in mass timber, you have guidance to designers in how to consider that in charring methods. So just one of the examples here with the picture that's on the screen, that was a full-scale testing program that happened with the NRC. And that informed a lot of the code changes that we're seeing now in the 2020 and the 2025. And so the level of comfort of the authority having jurisdiction can also dictate some of the design decisions. So early consultation can be critical in that collaboration piece. Environmental benefits are kind of a no-brainer. It's a renewable resource. It's a Canadian resource. It's available pretty much in every province. We have a vast forest that we can utilize, and when done well with different forestry management, it's a resource that we can use forever. And so there's obviously some embodied carbon potential as tree grows and is harvested. It sequesters carbon, so it's carbon positive. So there is some carbon that needs to be utilized in the fabrication process and shipping and everything. But when you offset to kind of the other industries, there's definitely some trade-offs there, and often wood comes out on top in a comparable way. In terms of the environment, there's also kind of the user experience to the atmosphere as well. So when you're in, there's research that have shown that when you're in and you're exposed to wood structures and wood finishes, there's kind of benefits to the end user in their performance, in overall user experience, and even health benefits. So there's that component that also needs to be considered when you're considering mass timber in your project.
So I'm going to talk about thermal and sound performance. And in some ways, mass timber acts exactly as you think it would act, and in other ways, maybe not. So thermally, in this project, we had CLT panels, which were acting as the load-bearing component for exterior walls, which meant that we had continuous wood around the entire building. And that made it very easy to install continuous insulation as well. Plus, wood itself has some insulating properties. And so thermally, it works quite well. Also, of course, if you have, say, a wood beam that penetrates a building envelope, it's going to be much easier to deal with that thermal bridge than, say, a steel beam that penetrates a building envelope. Sound performance, on the other hand, is not as good as you might think with wood. It does transmit vibrations quite easily, more easily, say, than a CMU or a concrete wall. So that needs to be taken into consideration when you have a solid CLT wall separating two rooms, or if in another building, not this one, if you have a multi-story building that has CLT panels for the floor slab, then you also need to consider acoustic separation strategies. So there are lots of resources available for that. In terms of tolerances, we discovered during construction that tolerances are very important for CLT, and it's very precise, which led us to a little bit of back and forth on the shop drawings. And another thing that that came up is that we didn't have necessarily specified the allowable tolerance, the gap between two panels. And so what we ended up with in some cases were spaces that were large enough, say, for a little child's finger to go into, which is not safe. And we had to deal with that on site. So specifying tolerances, finding out from fabricators and installers what is reasonable and possible with this type of product, and then being able to plan for any gaps that that end up happening is definitely advised. The other thing to note is about sort of the plumbness of it. So we, as you'll see later on in this presentation, we did run into some issues where the panels met the floor because they weren't entirely plumb or flush to each other. So that is something to note as well. And I think that there are ways that you can mitigate those through the way that you detail the panel joints. And that's something that we'll definitely be looking to do in the future. In terms of finishing, of course, there's the different coatings that you might put on it. CLT does come with a coating already on it from the manufacturer and doesn't need to be finished in any way. But if there are specific coatings that you'd prefer, then those need to go into the specification. Obviously, it's best to get those applied in the shop. Another thing to think about, though, is whether you're going to be seeing the wood or not. Then you're going to want to choose and specify different grades that are either have fewer imperfections, or if it's going to be covered up anyways, then you'll choose something that is specified as non-visual, because it's then you save some cost that way.
So kind of the final considerations before we jump into some project specifics here. Obviously, being a structural person, I have to think about structural properties. So mass timber and different mass timber products have different properties and inherently should be used in different ways. And so that should play into consideration in terms of decision making and in selection of the final structural system, as well as laying out some of the spaces, which we'll talk about later. One of the consideration is in terms of species. So keep that in mind as you're getting into some of the projects. We are in Ontario. We're kind of ideally focusing on utilizing materials around our area, and so trees that grow around here are more on the spruce, pine, fir type of species, and so those have different properties than when you compare, and also different aesthetics compared to some of the species that grow out west, such as like the Douglas firs or the hem firs. And so be very careful in considering what you're specifying on your projects, because that kind of takes away potentially from some of the environmental benefits. If you're sourcing material from the other side of the country, will play against your environmental benefits there. Manufacturers and fabricators is an important one. So because of the state of the industry, as discussed previously, different fabricators are going to focus on different types of mass timber products. So specifying CLT or NLT may not be coming from the same fabricator. So understanding the supply chain, who fabricates what and where it's coming from, can help kind of maybe simplify some of the projects as well, so that you can kind of focus on a single fabricator, or maybe a handful, instead of kind of picking and choosing from a bunch of different ones. They also have limitations in what they can fabricate. So depending on their presses and how they go through the manufacturing process, there's kind of discrepancies between some of the manufacturers in terms of thickness, in terms of the width of the panels that they fabricate, and the length of panels that they can fabricate. So that should all be considered as you're laying out spaces, so that you can potentially optimize the wood fibers that are being used, and you don't have kind of the waste sections of panels that just need to be cut off because it just doesn't work with what is being fabricated. Compatibility. Oh, before I move into compatibility, one other important piece is CNC cost. So all of these panels basically are fabricated in billets in standard lengths, and then they get cut up into smaller pieces. So anytime you're adding a cut, or you're modifying that component, you're adding cost and time in the fabrication process. Going back to some of the pre-fabrication or pre-install discussions earlier, that plays into the time for the shop drawing process, and also the time for fabrication ahead of getting to site. Compatibility is an important one. So compatibility in terms of materials, when you think of different systems and different materials coming together. So this example is from Brock Commons, which is, I think, is an 18-story building completed in BC for the University of BC. It's a resident building, and you can kind of see the two predominant material coming together with respect to a concrete core and then some CLT decks and columns. So just understanding the compatibility in terms of, wood is susceptible to moisture and dimensional changes. How does that impact how you're going to detail materials coming in together? So that's important when you're picking and choosing, and also mix and matching different materials. So that's was also an important lesson learned in our project. And finally, kind of compatibility in terms of how that fits into constructability. So sequencing and shrinkage, and time to site. So if you're mixing, say, open web joists and CLT, when are things going to be completed, and how are things going to be sequenced? So there's definitely compatibility in terms of scheduling that needs to be understood as you're specifying some of these products.
All right, I'm going to take you through the school design quickly before we get into the collaboration in design and construction part of this. So here's a plan of the building. North is up, and the large arrow is the front entrance to the building. The other arrows represent other entrances or exits out to the playground and into the corridors at each end. This is the reception and staff area. The reception is located close to the front entrance and to the parking areas for good visibility and security on the site. Then we've got the public corridor, which encompasses a sort of casual seating area and stair that's nestled in beside a ramp that leads up to the stage and cafeteria. This is a 3-season room, which is the cultural space for the school. They hold ceremonies here and other cultural events. And then we have the gymnasium in the center of this space, with storage to the north and change rooms and washrooms at the south end. And Above the change rooms and washrooms, that's where the mechanical and electrical rooms are. So it's a bit of a sort of mezzanine level. And this area is the kitchen and cafeteria and stage. So most days it's set up as a cafeteria and kids can come in for breakfast and lunch. And then when there's a large event or presentation or a production, it can become a stage and the gymnasium becomes the seating area. So it kind of doubles up in that way. And finally, in the kind of public facing spaces, we have the library and the multi-purpose room. Then we have kindergarten classrooms down in the south end, and those both have their own washrooms and cubby rooms that lead out directly to their own kind of fenced in playground area that's separate from the larger playground for the rest of the children. The school is separated into 2 wings, and so grades 1 to 3 are also in the south wing with the kindergarten classrooms, and grades 4 to 8 are in the west wing. And spread out across both wings, we have resource rooms and native language rooms, which kind of support the students that are located in either side of the building.
So the framing strategies is kind of divided into 2. The first is kind of this main central portion of the building, which is set on kind of standard foundation walls and footings. Above ground, the structural system is mainly load-bearing CLT walls in varying thicknesses. So the geometry for the gym and the round walls were actually done through panelization, so cutting the panels into 4-foot sections in order to work that radius around and work the circumference. There's a bit of a mix and match in this area, given that there are non-combustible material requirements for the roof. So we ended up with a steel deck on open web joists that's supported on the CLT walls. And then in that separation between the mechanical room and kind of the change rooms on the first level, there is a structural steel section which has a concrete topping on steel deck and steel beams. That's all supported on the CLT walls. There's a few other areas where kind of the focus towards the structure was emphasized. So there's the cultural room, which is all exposed wood decking on glulam beams and columns. And there's a few areas outside of that were also framed out of glulam beams and columns to kind of give the open spaces around the entrances and the kind of that seating area that Steph was talking about. Next, the 2 wings have very similar framing strategies. So again, CLT load-bearing walls, and those also serve as our lateral force resisting system, creating shear walls in both directions. We are, given that the NBC 2015 was used, we're basically just utilizing these as non-ductile systems. And so the roof above that is framed with parallel cord trusses. The geometry of the roof is a little bit challenging. And when you look at it in some of the pictures, you can kind of see that the idea is kind of a gable roof, but the peak of the gable is kind of skewed from corner to corner. So that created a very odd geometry for the framing of the walls. So what we ended up doing was framing the top of the walls, or sloping the top of the wall so that they could catch the plane of the parallel cord trusses. And the strategy in order to try to get a repetitive type of a construction there was basically utilizing girder trusses along kind of common elevation lines that match some of the ridge or that follows parallel to the ridge of the roof, and then that allowed for kind of more repetitive framing. So as we kind of got into the design and into the design, the collaboration piece was at the very forefront of the process. And so when designing using mass timber and mass timber components, there's definitely a shift in mindset that needs to happen. Most of the time, when you think of kind of a traditional type of a project design process, you have kind of the architects doing a lot of the pre-design and programming, and then structural kind of gets fit into the program, and that usually works well when you're thinking about a traditional kind of steel design and masonry design for these types of schools. In a mass timber project, it kind of has to happen more in collaboration. So sometimes the framing system, because of its limitation in terms of spans and typology of materials that you're using, can dictate some of the programming. And so the programming in some instances need to work around the structural framing. In this case, CLT is very compatible for this type of a building in terms of a school. The class sizes work very well for the spans and the capacities of the structural system. So when thinking about CLT specifically, there's also the collaboration when you think about mechanical, electrical systems. There definitely needs to be a little bit more of an involvement upfront with all of the different disciplines and everybody collaborating and buying into the process because of this prefabrication piece. So there needs to be a good strategy on how those systems are going to be distributed so that openings and chases can be coordinated upfront, and it's not a delegated thing that goes to the contractor, and it's more of an afterthought that often happens on other projects. So see, we're kind of running short on some time here, so I'm going to try to speed up the process. So some of the lessons learned, I guess, in specific to this project is in terms of material coordination. When you think about how open or parallel core trusses or who fabricates parallel core trusses versus CLT, it's definitely two different sides of a coin. And so in this case, we needed to do a lot of coordination and collaboration during the construction portion, because the way that the contractor ended up tendering this is basically as two separate contracts. Kind of thinking back as maybe a different strategy, it might be a better approach to kind of use a masonry type ideology for specifications where you have an all-encompassing common spec that basically forces one of the two trades to act as the prime over the other so that they can do the collaboration a little bit easier, and it's kind of one contract that makes it easier for the general contractor to manage. So that kind of plays into the delegated design piece, where when you think of the state of the industry at the time, and even still now, using steel as an example, there's a very kind of distinct line between the engineer record and what their responsibilities are, and say the steel fabricator and designer and what their responsibilities are. There's also guidance for designers to kind of formulate their contract documents to make sure that there's no gaps in the scope. When it comes to CLT and mass timber, that hasn't necessarily been established yet. So it's very important to make sure that all of those items are covered in the specification, and it's very clear where the engineer record responsibility starts and stops and where the fabricator's engineer starts and stops. Enhanced coordination is required at the foundation level. So Steph's going to cover kind of what's below grade, but even in terms of the fabrication tolerances for CLT is very tight. and you don't have the flexibility of adjusting on site as much, because kind of, when you think of wood versus steel, you can't weld something to kind of adjust for a field condition. So that upfront coordination and communication to the foundation contractor needs to be very well understood, so that they take a lot more attention in making sure that their foundations are in the right position, so that when the CLT gets to site, there's none of that that lag between the installation piece and kind of the adjustment piece.
So in terms of system coordination, you can see here in the bottom image, we've got the underground services. So we had main plumbing lines, electrical conduit, that all needed to be coordinated with things that were happening above the slab that hadn't been poured yet, and the walls hadn't been installed yet. So there was definitely some careful surveying that needed to happen here. And knowing what we know now, I think we would take a different approach to running these services, so that they didn't have to be quite so precise, quite so precisely placed, which impacted where they came up. So for example, you can see some of these conduits, they come up and they are meant to be flush against a wall. Well, we don't know exactly where that wall is going to be. And so in some cases, the conduit was maybe a couple of centimeters away from the wall, and then we needed to deal with that later on in the construction and finishing process. So there are other ways that you can do this, through chases, through channels between CLT panels, and even if it wasn't a slab on grade, obviously you'd have access to like a basement or something, and that would allow you to run these services differently. And then, of course, going back to what Sébastien said about coordination and penetrations through the CLT panels, those were all cut out in advance and coordinated in advance. And so small openings could be drilled through on site, but all of these openings were coordinated prior to fabrication and then brought to site in this way. And you can see also in the top image, we did have a chase there in each of the classrooms where we had millwork and a sink for washing hands. We were able to run some of the services in that space.
So I think the one of the biggest lessons learned was how to set expectations. So whenever you're getting into kind of a novel framing approach, or you're kind of using a new process or product, consider the state of the industry when specifying. So even looking at NMS spec available to us at the time, they were non-existent for CLT. So we had to start from scratch and kind of work with some of the manufacturers to try to come up with something that was representative of what the industry could actually achieve. So that basically works into kind of the importance of clear specifications, ID responsibility, talking about the gaps between delegated design versus the engineer record. It's making sure that everybody understands where that line lies and how that needs to be communicated on either the drawings or specifications. Same goes for the contractor. Like what is the responsibility of the general contractor with respect to this trade, especially if you're mix and matching materials, maybe having this common specification that encompasses the whole wood package, rather than trying to split the two, so that you have ownership of the wood package as a whole. Finishes is an important one. We worked that into the specifications, kind of making sure that temporary conditions are understood, that things are protected during construction, as Steph indicated, so that you essentially you're your first product is your finished product, and so you really need to pay attention to protecting that. Quality control measures is another one. There was limited guidance at the time as to what is the expectation in terms of QC and submittals, and also in terms of the site and what the responsibility of the contractor is to general conformance between the engineer record and the delegated design components. Moisture management is, if you've ever, based on the familiarity with mass timber, that's a very important one that plays into a lot of the detailing up front. And so depending on if you have multi-floors or single floors, then sometimes what ends up happening is your floor is your roof until the next floor goes up. And so moisture can become very important, especially when you're trying to control that and enclose and then finish. So temporary conditions, you can kind of see some of those in the pictures, just making sure that as the building gets erected, there's thought on how that sequencing is going to happen and what temporary measures need to be in place before everything is constructed and stable. Reasonable tolerances, I think, is one that we kind of talked about earlier, is just understanding what is feasible to build and making sure that the tolerances are communicated between the different trades, and that expectation is set and the collaboration happens before the mass timber gets to site. So prefabrication is a big one, especially when you're using a DC2 type contract. These types of projects have a very large investment on the contractor side. They need to pay for the material upfront, and so it is a challenge to navigate in the DC2 world, because I think the way that the contracts are set up, unless you have the materials on site, you're not necessarily paying for those. So it can become a cash flow issue for some of the contractors, depending on the size. So just as you're getting into these, depending on the amount of mass timber on the project, then that can play an important role in how specifications are tailored.
Sorry. Okay. Just a couple slides left, so we'll be brief here. So I'm going to talk a little bit about detailing. So when it comes to CLT panels, of course, we saw earlier that they are sort of ranging from 3 plies to 9 plies. And so the surface condition that you're going to get is different from the end condition. And so you need to think about whether you're going to decide to leave that exposed, or if you're going to put some trim on it. And in this case, we decided to cap the ends at both the ends of walls and at the corners, and create that consistent finish. The base condition, which you can see in the bottom right image. So we had linoleum flooring, and we specified a cove base. And what became an issue was with the panels, when they were installed, some of them weren't necessarily totally plumb. They weren't necessarily flush with each other. And so when you're installing this cove base, you don't have a consistent, flat surface to adhere it to. This is probably the 4th iteration of contractor attempting to make this work. And what they ended up doing was putting in a thin piece of, it was like an MDF or something like that, behind the cove base, and then so like a Schluter strip around the edges of it, and then the flooring wrapped up into that. Now, as you can see also, and what wasn't entirely resolved was as you have the cove base wrap up, there's a bit of a kind of gap at the radius in the corner that needs to be filled in or resolved somehow. In this case, we ended up doing it with caulking and kind of just massaging the material to fit. I would definitely come up with a more resolved and elegant solution next time. And that also kind of had to do with how we treated the door and window openings. So you can see the door trim is designed to be flush with the CLT, which for the same reasons of inconsistent tolerances became an issue where two panels met in the middle of a door, for example, and it couldn't be flush. So you kind of had to split the difference between the panels and make it just as good as we could. But it also became an issue when the base was coming up against it, and we had to then come up with a solution to finish the end of the cove base. I want to talk briefly about fire separations. So we did have some walls here that needed to be fire separations, and what was used for this project were butt jointed CLT panels. And of course, it's not perfectly, airtight when you have a butt joint. And so that was not going to keep smoke and flames from entering, traveling between the two spaces. So we did end up having to put drywall on one side of those walls. They ended up being, a washroom and a mechanical room and a storage room. So it wasn't a huge deal, except it was an extra cost. It wasn't a huge deal aesthetically. It was an extra cost. But that can be definitely mitigated, especially with further development with this material and different ways that you can join panels together, including interlocking joints and including sort of sealants and things between. You can make it so that you can have a fire separation that's exposed CLT on both sides. Okay, so closing thoughts, just quickly. The decision to use mass timber impacts all other design decisions. And so making that decision early on and incorporating especially the structural team is very, very important. You can't just design a building to be steel and then later on decide actually you want it to be wood. The spans won't work, and the regular grid is very important. Secondly, relationships built on trust and respect are very important, especially when using innovative new products. And then that leads into communication. So communicating what mass timber is, what it can do, what it looks like, and managing those client expectations throughout the process was really important for this project.
Early collaboration is very important for a successful project, especially when you're utilizing a new material. So having everybody buy into and learn about the new process is very important, especially for mass timber. There's different strategies for the M&E team, for example, that need to be really well understood so that you get things that are well coordinated and aesthetically pleasing as well. You want to avoid any field drilling and any field openings. So that all needs to happen up front before projects go out. So certain types of contract can also facilitate earlier collaboration. And in our case, we were kind of set with a CCDC2, but there are other ways to deliver projects. And when you look at a lot at the industry and the state of the industry as in the last years, most of the projects have been delivered through alternate delivery solutions such as construction managed or design build. So the constraints of the CCDC2 can be a bit of a challenge to navigate when you're utilizing a new material. Having partners in terms of a fabricator, for example, in this case, early on, could have helped inform some of the design decisions and manage maybe some of the waste that has happened or could have happened in the fabrication process. So just kind of aligning the design with a fabricator can go a long way.
Oops. So with that, that is the end of our presentation, and I'll open it up to some questions. Thank you for listening to us, and sorry we went a little bit over. I did just want to say we found out late last week that this project was selected as a finalist for the AZ Awards through Azure Magazine in the social good category. And if you follow the QR code there, it'll take you to that website where you can check out our submission. And if you like it, you can vote for us for People's Choice.
Okay. Amazing. Thank you so much, Stephanie and Sebastian, for this excellent presentation and sharing your beautiful project with us. As Stephanie mentioned, we're going to switch over into the Q&A portion of the webinar now. I already see that there's quite a few questions in the Q&A box, but if you do have a question for our speakers, again, you'll find that towards the bottom of your screen, so feel free to input your questions there. And if we need to go over a few minutes to get through the questions, we can do that. Okay. So our first question is asking whether the CLT is painted, and if yes, what is it painted with, or what's the material?
Sure. I'll take that one. So no, the CLT is not painted. It does have a protective coating on it, so like a clear coat that was applied in the factory. And there were some touch-ups that had to happen on site. So where damages occurred, the contractor came in, sanded down those imperfections, and then touched up the areas with the same coating in those spots.
Okay, great. Thank you. There's a question here about cost, but it's sort of more of a general question. So asking about the cost of mass timber, I think, compared to similar buildings with steel stud or even wood construction like conventional wood frames. I don't know if maybe there's a general sort of answer to that.
Yeah, I can take that one, Steph, if you want. So I think it has to be looked at kind of on a case-by-case basis. It really depends on most likely the volume of mass timber that you're trying to utilize as well. And I guess what I would caution is don't necessarily only focus on the structural system, because most often that's where the discussion kind of starts and stops, is it's more expensive than concrete or it's more expensive than steel. But you have to look at it as a project holistically. Steph kind of touched on the speed of construction. So there's kind of other soft costs that come in to play, where you can say even if you can save a couple months in construction, that can be quite a bit of cost to your project. The other one is finishes, and so there's a lot of time as well as cost to fire rate steel columns and those types of details that are often overlooked when you're doing the overall cost comparison. So there is a premium. It's often not as much as you would expect it when you look at it overall.
I will just add to that a little bit. So there's lots of things that you can do in design, decisions that you can make that will lower the cost of the system, and that includes making sure that you understand the sizes of the panels that you can get, or the sizes of materials, and designing so that you have the fewest number of cuts. Also, and this is a little bit less in your control, especially if with a CCDC2, but you'll want to have a contractor that has experience using the material. Obviously, and anybody knows this, if you're doing something for the very first time, there's going to be inefficiencies. They're going to price in some risk for that. So finding a contractor that has experience will definitely help the costs come in a more reasonable way.
Right,
Maybe
that makes sense.
also to to build on that, the delivery method as well in terms of the contract type, right? I think the CCDC2 is one thing, but getting the fabricator included up front that can help share some of that risk and cost between the owner and the contractor instead of kind of imposing it all on the contractor. So it can be a bit more of a balance if you can utilize alternate delivery methods.
Okay, perfect. Thank you. We have another question here about how you manage the acoustic separation of CLT, demising walls between classrooms.
Yeah, so in this case, we actually didn't do anything special. The CLT was a load-bearing element, so it did go all the way up to the underside of structure. And I'm not sure if you recall seeing in one of the previous images, we had to fire rate the roof. So there was a sheet of gypsum there as well. And so basically there wasn't any of that, the sound that you get sometimes over top of a wall from one room to the next. That was mitigated through just having the wall go all the way up to the structure and be sealed on either side. So then the main one that we would be dealing with is the sound vibrations through the wall. And in this case, as a single-story building, it wasn't as noticeable or as, like I haven't heard any complaints, let's say, from the teachers. I've been back a few times in terms of sound. And yeah, so the sound concerns come into play primarily when you're in multi-story buildings and you're having like footfall sounds and stuff like that. So you need to control for vibration.
Right. Okay, great. Someone has asked if you can elaborate on steel connections connecting the mass timber elements.
Sure, I can take that one. So, I mean, that's part of the delegated design component. So in this specific case, we impose that on the CLT fabricator to coordinate. In some instances, the easiest way to deal with connection is through bearing. So in any case, like for most of our steel framing that was framing into the CLT walls, we just had recessed pockets that were CNC'd out to receive the steel element. So in some instances, we needed to utilize hangers. So there are some proprietary products, if you think of kind of the Simpsons and the MTCs of the world, that you can use. But depending on who the supplier and manufacturers are, most of the time they revert back to their own kind of systems and often would fabricate saddles and those types of elements in-house so that it's coordinated and works with all of their CNC'd connections.
Okay, great. Thanks, Sébastien.
Um,
Someone has asked here, how dimensionally stable is the CLT material relative to extreme cold or warm/humid conditions at the time of initial installation, pending building envelope completion to protect and condition the wood?
I can take that one as well if you want, Steph. Okay. So usually the way that the mass timber products are fabricated, they need a certain moisture content when they're assembled. So there's tolerances in their fabrication, in the fabrication processes. They're quite dimensionally stable. When you think of how much time it takes for an element to absorb moisture, most often it exceeds kind of the construction period. So there is going to be a little bit of movement depending on when and where things are going to be fabricated and the time of year as well. But it's not as much as you would think when you say compare to like a nominal wood frame as an example.
Okay, great. We have a sort of multi-part question here. So someone has asked if you can clarify the responsibility of the engineer of record and the CLT design engineer. How does the municipal building department see the roles? And then are CLT engineering docs submitted with the building permit application?
Good question.
Can I
Um,
quickly
yeah,
start?
go ahead. Sure.
So just before jumping in, I think maybe Sébastien, you can speak to like what happens in a typical project. In this project, however,
Yeah.
it was built on Indigenous land, so on First Nation, and so there wasn't an authority having jurisdiction, so there was no building permit application either. So that kind of changes the liabilities and all of that stuff as well, but. Maybe I'll pass it back to Sébastien to talk about sort of a typical situation.
Sure. So basically, the engineer of record is responsible for general sizing of elements. So the panel thicknesses, the general sizes of lintels, and those types of things. In some situations, some of the engineers are taking on the connection design. It really depends on kind of the level of experience, I guess, of the engineer record and how far they want to take that component. But the way that we have approached these types of projects is kind of more along the lines of a steel fabrication, and so we delegate the design of the connections. We found that fabricators often have their own ways that they want to CNC or to construct, and therefore there's kind of an inefficient process in us dictating how connections are going to be assembled. So that's generally the process, and unless there's like an aesthetic requirement or a fire separation requirement or fire resistance rating requirement for a connection, that all needs to be communicated in terms of a concept, so that the constraints and the bounds are set for the manufacturer and their engineer. There is no submittal of components in terms of what the CLT is to the authority having jurisdiction. It's treated kind of just through a normal shop drawing process. I think did I cover all of the question?
The last part was around engineering documents submitted. Are they submitted with the building permit application?
They are not. No. The documents are basically that are submitted are the specification, which encompasses the responsibility of the delegated design components, and then in the general contract documents.
Perfect. Okay. Someone has asked whether the mass timber spec sole source did the mass timber spec sole source fabricators so you could work with one fabricator during design, or did you have to keep it open to any fabricator due to public procurement rules?
I can start with this one. You
Sure.
can maybe jump in.
Yep.
So technically, no, it was not sole sourced. However, as Sébastien kind of alluded to earlier, different fabricators have different dimensions of materials and things like that. And so in the specification, when we said, the panel thickness must be this much, that basically narrowed it down to the one supplier that supplied that thickness of material. So in the original bid, the contractor did carry that fabricator that we expected that they would. And then it turned out that with the shortage of materials at the time and the long lineup of people who wanted to use wood and CLT products, it was going to be a very, very long wait to even get, to even start fabrication. And so in the middle of the project, we switched through conversations with the contractor. This is probably one of the most tricky conversations we had, but through the conversations with the contractor and the client and Timmerman, who was the installer, we ended up switching to a different supplier, which was Element 5 in the end. And so we actually did have to make some modifications to our drawings, increased wall thicknesses and making sure that the rooms were still the right size per the SSAS requirements. So those are basically the requirements that say that Indigenous Services Canada will fund a certain size of school and the rooms must be such a size. So because the wall thickness has changed, we had to change these things. It was actually a pretty big undertaking, but it did basically cut 2 years off of the construction process. So worth it in the end, I would say. Sébastien, I don't know if you have anything to add about that.
Yeah, to add, I think the state of the industry at the time was kind of the main driving factor behind sourcing kind of focusing on one fabricator. Anytime there's kind of an evolving technology, there's always kind of a front runner, and so they're ahead in terms of available information, in terms of the support that they offer during design, those types of things, and so. That definitely favored one versus another, as Stephanie alluded. But now that there are multiple supplying these types of materials, then that opens the door for a more competitive bid. But you still need to understand what those dimensional tolerances need to be or capabilities are between the different fabricators, so that you can work that into your programming and into your design.
Okay, great. Thank you. Someone has asked here, are there sufficient ULC rated assembly details to satisfy typical fire rating scenarios of walls and floors, penetrations, etc.?
Do you want to take this one, Seb?
Sure. So again, state of the industry is important kind of preamble to this. So at the time when we were looking at the 2015 NBC, ULC ratings were kind of limited, and so it also played into the decision of sourcing Nordique versus, or kind of emphasizing our spec towards Nordique versus others, because they had gone through some of that testing process and they had equivalencies available to us in how to detail those different conditions. Now that the industry has evolved, and even the 2020 version of the NBC opens the door to kind of this alternate solution, which is called the CHAR method. So for kind of load-bearing walls and floor assemblies, there's a way to design your elements to incorporate kind of additional materials that gets consumed through an event. So if you think of a 45-minute or 60-minute separation, for example, wood chars and is consumed at a very consistent rate, and so you can kind of understand how much of that portion of the structure is going to be consumed in the event, and whatever is left in the center still has inherent structural properties. So you can tailor and design your elements in accordance to kind of the spans and the demand. I think maybe Steph, I don't know if is there more ULC kind of details that are available in some of the connections and those types of things now?
I'm actually not sure. Don't know the answer.
Okay, great. We'll take maybe just a few more questions. We'll go slightly over time if that's okay with our speakers as well. So someone has asked, was the CCDC2 a requirement of the community or a requirement from ISC?
So it was a requirement from ISC, and as far as I know, still remains a requirement from ISC. So yeah, it's just the way that the process works in terms of funding. I can go into it a little bit. So at the start, there's a feasibility study with very high level costs that goes off to IFC to be, for approval or comments. And then it goes through the entire design process, which ISC does attend some meetings and gets updates on the anticipated costs throughout that process. And at the very end, it has to go out to for Class A cost estimate. And then the whole drawing package and the Class A cost estimate go to ISC for their review. And based on that, they approve a certain amount of funds for the project. And once you get approval to proceed, then you can go out to tender. And so you can see how with those various stages of approvals, it's challenging. I haven't seen it done where there's another contract method, say like a design build or anything like that. Though I'm hopeful that we can move towards that.
Okay, great. We'll take just one more question. So someone has asked, and I know that you mentioned this earlier on in the presentation, they might have missed this, but in terms of who you collaborated with on the project, they asked, were teachers, students, parents, community members involved? Were they involved at all stages? And I want to just add a follow-up to that question as well. You mentioned that you've received some positive feedback from the community members and the students afterwards. I wonder if you could elaborate on that a little bit as well.
Sure. Yeah, so we did engage with all of those people. Anybody who wanted to attend the engagement sessions at the start were welcome to. And so that did include students, teachers, staff members, community members. So anybody really. And further on in the process, we did, as we were talking about specific rooms, so when we were talking about the gym, we invited the PE teacher. When we were talking about the resource rooms, we invited those specific teachers and providers. So then it was more of on an invite basis based on like the thing that we were talking about. But then also, of course, we did regular presentations to chief and council as well. So we kind of prepared PowerPoint presentation, talked about where things were at in the project, and that was available for a broader audience in the more detailed design stages. So yeah, the feedback that we've received, I mean, you learn a lot too, but the feedback is overwhelmingly good. Students, the best time that I have is when I go to the school and the students are just running around playing in the gym or engaging in some artwork in the multipurpose room. So just I take the smiles on their faces as good feedback, but you get the odd comment from teachers as well. I think just it's like wood, it's literally wood everywhere in the building, all of the walls. And so it's a really different kind of feeling. It does not feel like a school space. And you can really kind of sense that when you're there. There's the odd thing that we've learned too, like don't put cabinets way up high where teachers have to climb on ladders because then they have to do some like working at heights training, which doesn't make sense for teachers. Right. So yeah, there's the odd little thing where they're like a little bit annoyed, and that's okay.
I think one other thing, like from lessons learned there, is just like the surfaces are wood, so kind of splinters are or can be a risk. So just kind of thinking about the detailing at the base of the wall for especially for smaller children and in those types of classrooms, they're prone to touch everything. So
yeah, right. The contractor was actually really good. So obviously, like it's expected. It's a natural material. It's going to have a few splinters and things like that. And when we were going around at the end to do the deficiency review, we kind of pointed out some of those items which were not the contractor's fault in any way. But we just asked very nicely if they could, like the ones that were within reach of people, to remove them. And they did, which was great. So
Okay, great. So apologies if we weren't able to get to your question. There's a few in the chat that, or sorry, in the Q&A that we didn't get to, but I can see Stephanie and Sebastian's emails are up on the slide. So if you would like to get in touch with them with further questions, you're more than welcome to do so. I will just transition quickly into our closing announcements. But before I do that, of course, a big thank you to Stephanie and Sebastian for sharing this beautiful project. I'm sure our members learned a lot from it as well. So thanks again for this presentation. And thank you to our attendees for submitting all of your questions and for your engagement today as well. So as we conclude this webinar, again, a few quick announcements. For those who are seeking continuing education learning hours, again, the OAA will record your participation in this webinar on your OAA transcript. So there is no need for individual reporting on your part. We just kindly ask for your patience at this busy time of year as we process and confirm the accreditation of your hours within the next few weeks. All attendees are going to receive a link to a survey along with a link to the presentation slides. But again, you'll receive a link to the survey to give feedback for our speakers today. We at the OAA and our presenters highly value this feedback. So if you do get a moment, please do fill out that survey once you receive the link. So continuing on with our Earth Day theme, our next webinar takes place tomorrow, Thursday, April 23rd. This is another climate action webinar with the title Collaboration for Circular Construction and Reuse. And this is presented by the CEO of Green Salvaged Materials, Carly Connor. For a list of our upcoming webinar offerings, check out the Continuing Education Webinar Series page on the OAA website. And if you are looking for additional ways to get your Con Ed hours before the end of cycle, be sure to also check out the Con Ed Opportunities page, where we list continuing education opportunities offered by other organizations beyond the OAA. With that, I will thank Stephanie and Sebastian once again for this presentation. Thank you to all of our attendees, and I hope you have a pleasant remainder of your day. Thanks very much.
Thank you.
Thank you.